Hello, in this video we talk about the call options payoff diagram. So we talk about risk profiles of call option buyer and seller, right? Buying a call option gives you the right but not the obligation to buy the underlying security at the given strike price. Therefore, a call option payoff at expiration depends on where the underlying price is relative to the call option strike price, right? So in this notebook that you see, we will plot a call buyer's and a call seller's payoff graph for a 90 strike price call on the XYZ stock. XYZ is a hypothetical stock that we just use, right? It's not a real company. Okay, so how do we start? So we start by importing the libraries that we need. We import NumPy S and P. For plotting, we import matplotlib pyplot as PLT, and then we also say a specific style that we want to use. There are different styles available. You can look up on Google, then you will find. All right, so we run that cell first. So let's understand call payoffs, right? So we define a function called payoff that is here that calculates the payoff from buying a call option, right? The function takes ST, that is the stock price. One second. That is the stock price, a range of possible values of the stock price at expiration, right? The strike price of the call option and premium of the call option as input. It returns an umpire array containing the profit from call option for different stock prices. When the stock price is greater than the strike price, the profit is the difference between the stock price and the strike price. And when the stock price is less than the strike price, the profit is zero. After this, a call premium is deducted from the profit and loss, right? Let's look at the function again. So as I said, here are the stock prices. That will be an NP array or just a single value, a scalar, right? Or strike prices. That is the strike price that you buy an option. And the premium is how much you pay to own that contract that gives you the right but not the obligation, right? So the P&L calculates like that. So you compare the stock price with the strike price. If the stock price is greater than the strike price, then you are in profit, right? Then you say if that condition is true, then the stock price minus the strike price. If it's not true, then we say zero because we don't pay, right? The only thing that we have to consider is at the end the P&L minus the premium. That's the cost of the option, right? If you look at the option chain, you will see the associated cost for owning a specific call option. That's why we have to deduct, right? Now let's define some sample parameters to plot our graph, right? So we say spot price of 90, we say strike price 90. When the strike price and the spot price are the same value, we call it, the moneyness is called at the money, right? If the spot price is bigger than the strike price, it's called in the money. And if the spot price is below the strike price, that is out of the money, right? So the premium is the cost of the option. And here with this one, we generate an array of different stock prices, taking the spot price and say from 90% of the value is the beginning and 110% of the value is the end. And we generate an array. If you look at what we have generated, is just a linear increase of different spot prices that we simulate, right? And then to draw the call option buyer payoff diagram, we just calculate the call payoff for the stock prices that we synthetically generated here. We provide the strike price that we have defined here and the premium that we also have defined. Then we set the canvas of size 20.9. This is 20 in X direction and 9 into Y direction. Some description, and that's what generates the plot, right? We provide for the x-axis, that's the x-axis, the stock prices, synthetic generated. Then the payoff for each stock price, what is the payoff or what is the profit or loss, right? And then we label it call option buyer payoff. You see the label on the top left, right? If you run that, you get a plot. That's the payoff diagram for the call option, right? For the strike price, premium, that we have provided in the above. So what do you observe here? So what do you, if you look at the diagram, what do you observe? So even if the price of XYZ goes below the strike price of 90, so here's 90, if it goes below, right, the maximum loss seems to be just 4. That's the cost of the premium, right? Whatever the premium is that your maximum loss. Obviously, the contract size you have to consider. For normally for US stocks, you have a contract size of 100. That needs that number has to be multiplied by 100. So in that case, 400 is the loss. Therefore, the loss to the call option buyer is restricted to the extent of the premium he has paid. The profit from this call option seems to increase linearly, as then when XYZ starts to move above the strike price of 90, therefore the higher the spot price goes from the strike price, the higher is the profit, right? So you see slowly increasing, and the break even must be around 94. You can obviously calculate the exact number. And from the, so here you have zero loss and zero gain. But if the value of the stock goes above that value, so you are now in the green zone and everything is your profit. The profit is linear increase. Okay. So through the call option is supposed to make a profit when the spot price moves above the strike price. The call option buyer first needs to recover the premium he has paid. So this is the recover period, right? From the strike price to the break even. That's recover period time. So from the above points that we have just mentioned, we can say that the buyer of the call option has limited risk and the potential to make an unlimited profit, right? That's the limited risk. No matter how far the price falls, we still pay the same amount, and that is the premium amount. So the unlimited profit is if the stock price goes to infinity, right? So let's see, call option seller payoff diagram. So let's say you are selling or you're writing a call option. So how would the diagram look like? So option buyer and option seller are two sides of the same coin, right? Therefore, to get the payoff graph for option seller, we have multiplied the payoff of option buyer by -1, right? Because it's two sides of the same coin, so it's the inverse. So as when the option buyer makes the profit, the option seller will lose the exact same amount and vice versa. So if someone writes an option, a call option, he will receive the premium from the buyer, right? And when the stock price increases above, then the option writer, will slowly to lose his gains from the premium, and that's the break even. After the break even, he will lose the money and has to pay the buyer of the call option. So the call option seller payoff looks like a major image, looks like a mirror image of the call option buyer payoff. So the profit is restricted to 4, the premium price, as long as the spot price is trading at any price below the strike of 90, right? Below 90, we keep our 4. If it's above 90 but below the break even, we keep as much as is left. From 90 to 94, we can see the profit getting reduced. Above 94, the call option seller starts losing money. The losses increases with an increase in stock price. Therefore, you sell a call option only when your view is that the underlying asset will not increase beyond the strike price, right? So, and now if we combine both payoff diagrams from call buyer, long, and call writer, then you will see that diagram, right? Okay. So thank you. That's it. I will attach the notebook in the description below. Feel free to download it and experiment yourself. Okay. Thank you.